images you were looking at were the first images the NASA took with the James Webb Telescope. Some people think the telescope is a normal telescope, but it's not. It's actually much more than that. It's really powerful. It's actually 100 times more powerful than the Hubble was. The Hubble could only go 340 miles away from the Earth, but the James Webb Telescope can go 932,056 miles away from the Earth. The James Webb Space Telescope works in the infrared spectrum, which is invisible to humans. But the infrared radiation allows the James Webb Space Telescope to see stars forming. There are many stars in galaxies, but for you, they are too far. But how does the JWST see them? The JWST has a huge mirror, which increases the amount of light the JWST has. Basically, the more light it has, the more the image is detailed. The mirror is made with 18 segments. This shape allows the telescope to fold in Earth and then unfold in space. The telescope has 4 tools. The first one is called NIRCam. NIRCam is equipped with chromographs. Basically, what chromographs is imagine you're outside and you can't see so much. So when you block the sun with your hands, you can see more clear. That's basically what a chromograph is. NIRCam can take photos and see exoplanets, but it can't see if there's light on the exoplanet. That's where the second tool comes in. NIRSpec studies the spectrum or color of light. You can tell its mass and temperature from that. To see the smallest light, the telescope has to stare at the object for 100 hours. To avoid wasting a lot of hours on one object, the NIRSpec was equipped with the power to provide spectroscopies of hundreds of objects, which lets it focus on more objects than just one, making it so that it saves time. That process is called micro shutter system. When you look at a city sky versus a small village, you can probably see more stars in a small village because cities have a lot of light. In space, there is a lot of light, so how to see the needed light? The James Webb Space Telescope has to move a lot for that to happen. The third tool helps it do that. The Fine Guidance Sensor, or FGS, allows the James Webb Space Telescope to move a lot to see the needed light, and so it can see the planets and stars. Even though the 3 tools make the James Webb Space Telescope way more easier to use, there's still one more problem. The James Webb Space Telescope encounters a lot of thick dust clouds. That's when the last tool, MIRI, comes in. MIRI is also equipped with a camera and a spectrograph. It works with another range of thick dust clouds, one with longer waves which can see through this thick dust clouds. But if MIRI is not cooled to -447.61 Fahrenheit, it starts capturing its own heat. So scientists created something called a cryocooler. It's kind of like a refrigerator which cools MIRI. But because of that, there's another problem. The sun, moon, and the earth is giving heat to the telescope. Because of that, the solution is that scientists build a sun shield which has 5 layers. For the sun shield to work, the James Webb Space Telescope has to be 1.5 million kilometers away from the Earth. The James Webb Space Telescope revealed a lot of new information we never knew about of our universe. But one thing I really liked that was revealed recently was that Saturn isn't the only planet which has rings. Uranus, Jupiter, and Neptune has rings.